How do we represent a linear polynomial? Now, we represent a linear polynomial in variable x as px equals a times x plus b, where a is the coefficient of x and where a and b are both constants and a cannot be equal to 0. So what do we mean by this? So for example, let's say we have a polynomial px which is 2x plus 6. Now we know that this is a linear polynomial because this is a polynomial of degree 1. And any polynomial of degree 1 is a linear polynomial. Now if we compare this with ax plus b, now here a is equal to 2 and b is equal to 6, right? Now the condition also said that a cannot be 0. So can we have something like, for example, px with the a coefficient of x is 0, and then this can be any other number? We actually cannot have that. Why? Because if we multiply 0 with x, so the polynomial will become, this term will go away and then we will be left with the term b, or in this case 2. And this is not a linear polynomial, right? Because all linear polynomials must be of degree 1. So for example, these are examples of linear polynomial. Say 3x, or we can say maybe 5x plus 10, or we can say 3y minus 6, or we can say simply y. All of these, so here these two are obviously px, these are polynomials in variable x, and these are polynomials in variable y. So we will represent them something like this, these two, right? But the point is, these are all examples of linear polynomials, and we cannot have the constant a being 0, because if we do make the a, which is coefficient of x, if we make a 0, then this entire term goes away. And if this entire term goes away, then we are left with only b, which is a constant term, and hence we will not have a polynomial. But the term b can be 0. So we can, like the way we just now saw, we can have simply px equal to, say, 2x, and this is an example of a linear polynomial. Or we can have 5y, which is again example of a linear polynomial. So b can be 0, but a cannot be 0.